find the real solutions, if any, of each equation here. Now these are radical equations. They both involve square roots. And we want to figure out the value when I plug it into x makes the equation true. Now when you're dealing with radical equations, the first thing you want to do is isolate the radical on one side, like it is here in this first example. The square root of 3x plus 10 is isolated on the left. Now once it's isolated, figure out what kind of root it is. This is a square root. So what I'm going to do is square both sides to get rid of the square root. The square root and the square operations are inverses, so they kind of undo each other. So what I'm going to do here is make sure that the square root is isolated. Now I'm going to square both sides. Square the left and the right. Now you have to be careful at this step because this step may introduce false solutions. So in order to figure out if a solution is false or not, we're going to have to check it in the end. All right, the square root and the square here, they undo each other, they go away. So we're left with 3x plus 10 on the left-hand side. And on the right-hand side, we have 16. Now I'm going to solve this for x. I'm going to subtract 10 on both sides. I get 3x equals 6, and then divide by 3 on both sides, and I get an answer of 2. But whenever you're solving radical equations, you want to check your answer. Always check your answer. So I'm going to take this 2, and I'm going to plug it into the original equation here. So I'm going to check it. So I'm just going to rewrite the same thing, but I'm going to plug 2 into this x spot right here. So 3 times 2 plus 10, does that equal 4? Now 3 times 2 is 6, 6 plus 10 is 16, so this is square root of 16, which is, it looks like it's coming out right. Square root of 16 is 4, so this one looks good. So I'm going to keep it. If it turned out bad, I would have just thrown it away and there would be no solution in this case. All right, let's look at this second example. Now remember, the first step is to isolate the radical. This one's not isolated because I have a plus 3 here. So I want to subtract 3 on both sides. So I have square root of 2x plus 3 equals negative 3. Now the square root of anything is never negative, so if you knew that, right away you could be like, well, there's no solution, there's no real solution to this. But let's say we didn't know that and we wanted to solve it, so we'd square both sides. Now when you square both sides, you're going to need parentheses on the right-hand side. So then I have 2x plus 3 equals positive 9, because negative 3 times negative 3 is positive 9. Subtract 3 on both sides, you get 2x equals 6, and then dividing both sides by 2, we get a value of 3. But this is going to be an example of 3 being not a solution. Because if you go back to the original equation and check it, I'm going to plug 3 into right here. Let's see if this is true or not. 2 times 3 is 6. 6 plus 3 is 9. So this is square root of 9 plus 3 equals 0, which is 3 plus 3 equals 0, which is 6 equals 0. And that's not good. So this means this is not a solution. So the answer to this one, you're going to say no real solutions. So the first one we have a solution, it's 2, and it checked out. But this next one, as soon as you get a square root equal to a negative number, you can stop right there and say there's no real solution. But if you do go in through it and get it, you get a 3, that's not the answer. Check it, it didn't work. So the answer to this one's no real solutions. There you go.